We will begin with this explained article. Scientists use outer space particles to examine the fortress wall of Xi'an city. That outer space particle is muon. Researchers in China are examining the fortress wall of Xi'an city. This is the fortress wall as you can see here in the picture. It is 12-meter high and 18-meter wide. All of you must be familiar with the concept of X-ray imaging. Muons basically do the same thing but at a larger scale with more accuracy. So when you do the 3D imaging of any wall or any structure, you know the density of material in the structure at various points in space. And that's how you find out the vulnerable points, because at vulnerable points there would be more cracks, more cavities, and hence less density. So density anomalies can be found out and potential safety hazards can be known. That's the entire idea. But we'll take the topic step by step and we'll do the things important for the exam. First of all, I'll very simplistically introduce the concept of muon. So we'll do a little bit basic of particle physics to explain how the universe behaves, how the different particles in universe interact with each other. The present theory to explain that is Standard Model. UPSC has once mentioned Standard Model in its discussion in 2017. UPSC asked, the term event horizon, singularity, string theory, and Standard Model are sometimes seen in news in the context of. The answer is option A, observation and understanding of the universe. And you know, if UPSC mentions once a term in the question, it is likely to ask something more advanced about it in future. So knowing elementary points regarding Standard Model won't hurt. And it is important to know a little bit of Standard Model to understand the advancement that is happening in the field of astronomy and particle physics, about which you often read in news. So here we go. We'll do only very basic, only to the point which is relevant for our exam. According to this Standard Model, there are 3 elementary particles in nature. And quickly bring them in your consciousness. There are 3 elementary particles: quarks, leptons, and bosons. You know, inside the nucleus of an atom, there are protons and neutrons. Protons and neutrons are made by combination of quarks. So quarks basically help develop the nuclei of atoms. Protons and neutrons which reside inside the nucleus. And outside the nucleus you have electrons. Electron is a form of lepton. Lepton is the second elementary particle. So electrons which are outside the nucleus within the atom, they are a kind of leptons. There are 6 kinds of quarks and there are also 6 kinds of leptons. Electron is a lepton. Muon is also a lepton. Tau is the 3rd kind of lepton, and there are 3 more leptons, which are 3 types of neutrinos. So neutrinos are also leptons. That's it. You don't have to know more than this regarding leptons. There are 6 kinds of leptons: electrons, muons, tau, and 3 types of neutrinos. So electrons are leptons, and what's inside the nucleus? They are quarks. Then there is a 3rd kind of elementary particle called as boson. Bosons have been named to honor Indian scientist Professor Satyendranath Bose. And boson is a collective name given to particles that carry force. You know, fundamentally, there are 4 kinds of forces in nature: electromagnetic force, strong nuclear force, and weak nuclear force. The particle that carries the force is boson. The particle that also helps in conversion of one particle into another, meaning change in mass, is also boson. Bosons are force carriers and bosons are mass converters. You know, in radioactive reactions where one particle converts into another, for example, alpha particle disintegrates to form beta particles and other particles, there the mass of different particles are different. So that mass conversion, that is also possible through bosons. The boson that is responsible for gravitational force has not been discovered yet. That's why gravity is not considered as a force under Standard Model. Gravity rather is considered as an interaction between 2 particles in the space-time. For example, if there is curvature of space-time like this, and there are 2 particles kept like this. So under the influence of curvature of space-time, these 2 particles will come together. And this is how gravitational pull of 2 particles for each other is explained. So basically the particles roll over the curvature of space-time to come together rather than coming together because of any force of attraction. The reason why gravitation is not considered as a force because we haven't discovered a boson corresponding to force of gravitation. We have boson for electromagnetism, strong interaction and weak interaction, but we do not have a boson for gravitational force. So gravitation is not a force under the concept of Standard Model. So the long and short of it is this. Under Standard Model, there are three kinds of particles: quarks, leptons, and bosons. Protons and neutrons inside the nucleus, they are made up of quarks. Electron outside the nucleus are leptons, but there are 5 more leptons. Muon is also a kind of lepton, which is a particle of interest in this section of our discussion. Tau and 3 more types of neutrinos, they all are leptons. So what does quark do? Quarks do confinement, meaning it puts particles together as it is inside the nucleus. Leptons gives mass and spin, magnetic moment to particles, meaning it helps in interaction with the surrounding. And what does boson do? Boson helps in carrying the force. It also helps in mass conversion. So it is important when one particle gets converted into other particle. So these 3 particles pretty much explain the phenomena in our universe, but not everything. That's why the physicists are now looking beyond Standard Model. For example, dark matters, dark energy, they are not explained by Standard Model. So what do we do now? We study muon. So we'll look at some of the properties of muon with the understanding that muon is a kind of lepton. Muon is a lepton. It is also considered as a big brother of electron because it is like electron. Why? Because electron has -1 charge, muon also has -1 charge. So electrically they are the same, but mass-wise, muon is much more massive. Muon is approximately 200 times more massive than electron. And that makes muon the second heaviest lepton. Remember, electron, muon, tau, and 3 neutrinos, they are leptons. The heaviest lepton is tau. Second heaviest lepton is muon. Third heaviest will be electron, and the lightest would be neutrinos. You know, they have negligible mass. Now, this is important to note in the beginning because this will dictate the property and the manner and the way in which muons are going to be used by mankind. Muons are heavier than electron, approximately 200 times more heavy. Now, this has a significance. It is not as heavy as nucleus, but it is much more heavy than electron. You understand what it means? It means that in an atom, there is nucleus and there are electrons. So the electrons won't be able to stop the muon because muon is much more heavy. That is why muon will be able to penetrate through the atom. Because these are lighter particles, they won't be able to stop muon. Electron is much lighter than muon. And that gives the penetrating power to muon. That means it can penetrate through the material and tells us what's inside. But you also understand that muon has negative charge. And like charges repel each other. Electron also has negative charge. Muon also has negative charge. So there would be some kind of electrostatic repulsion. Mass-wise, muon will dominate. But charge-wise, both electron and muon have same charge. So electron would be able to electromagnetically repel the muon. So muon won't go through and through the material indefinitely. So it will go to certain miles and after that it will get absorbed and disintegrate into further other particles. But since it is heavy, it will be able to penetrate to certain miles. And that is good enough for us. You also understand, had it been neutrino has negligible mass, but it is also electrically neutral. And because of neutrality, electrons' electromagnetic repulsion won't operate on neutrino. So the penetration power of neutrino is huge. It can penetrate through the earth as a whole. But muons cannot penetrate so much. But muons are more penetrating than X-rays. X-rays can penetrate only a few centimeters in metals. Muons can go till miles. So big structures, the pyramids, bridges, walls, they all can be 3D imaged using muons. You cannot do that by X-rays or any other radiations or particles like neutrinos because we are not advanced enough to detect neutrinos with such high precision. So muon seems to be the best particle at the moment to do 3D imaging of structures. Why? Because it has mass much more than electron. However, muons are very unstable and their lifetime is around 2.2 microseconds. Because of their instability, they will eventually decay into other particles, neutrinos and other particles. Where do they come from? Muons are generated when cosmic rays they enter into Earth's atmosphere and collide with particles. I hope you have a little bit of basic understanding of cosmic rays. They were generated when there was Big Bang and they travel almost with the speed of light. So at that velocity, when there is collision with particles, there are generation of new particles and muons are generated naturally like that. And naturally around 10,000 muons reach every square meter of Earth's surface. So we don't have to generate them. They are already there in Earth's atmosphere reaching to Earth's surface. All we have to do is detect them. Muon has a spin of half. Don't bother by this number. Spin is a quantum mechanical property. Just like we have mass, we have electric charge, we have magnetic moment. There's something called as a spin. Because of spin, just like electrons revolve around the nucleus, muons are also particles that rotates around its axis. And that give it magnetic moment. See, these two things, don't bother about them. I'll just simply explain you a fact. These two things basically means when you put this particle in magnetic field, they will start rotating. And when they rotate, they develop their own magnetic field. And that magnetic field is going to interact with other particles in the surrounding. So basically it means muons interacts with particles in the surrounding. So it will get disturbed by other magnetic fields. So it will get disturbed by electrons. So eventually it's going to stop penetrating. But still it can penetrate deeper, till miles into certain materials. It can penetrate through metals, through concretes, through any hard material. So ladies and gentlemen, that is what a muon is. Now let us see how do we use it. Tomography, you must be familiar with this term. This basically means imaging and generally using X-ray. So muon tomography meaning you would do imaging using muon. It is also called as muography. Muography is conceptually similar to imaging done by X-rays, but capable of doing imaging at much larger scale in much wider structures owing to its higher penetration power, as we have just discussed. As these high energy particles are naturally produced and they are ubiquitous, they are present everywhere. All one needs to do is place a muon detector underneath or within the structure or near the object of interest. Suppose there's a pyramid and pyramid hosts lots of secrets of human civilization. Because of muography, we now come to know that there are secret chambers within the pyramid. And in the Queen's Pyramid, there are long chambers. It is also likely that there would be certain manuscripts, some artifacts safely placed within this pyramid. And once we do the imaging and we know concretely, then permission can also be granted to dig tunnels at the right place and take out those manuscripts and read into the secrets of human civilization that we do not know yet. So how do we do it? Either you place sheets beneath the pyramid. We dig a tunnel and put the sheets, spread the sheets within the pyramid. There are muons coming all the time. And every point on the sheet can detect the intensity of the muon, and difference in intensity received on these plates tells us the difference in density of the material. So if there is hollowness inside, less of the muon will be absorbed and more intensity of the muon will be received on the sheets. So basically you do this exercise from all the sides. You put a receiver here and this will rotate and receive the muons from this direction. Similarly, you put a receiver here and it will make it possible for us to do the 3D imaging of this structure. It's simply that. This technique was first used in late 1960s to search for hidden chambers in the Pyramid of Giza. But nothing was found at that time, perhaps because the sensitivity of the instrument was less. However, in 2017, modern archaeologists repeated the experiment with more sophisticated and advanced muon detectors, and then they stumbled upon a major finding. They did the imaging of the pyramid and they found the Queen's chamber. There were also adjacent corridors within the pyramid. And this way, the archaeologists were able to discover a previously unknown chamber at least 30 meters long. So you understand how archaeology can advance using muography, how our understanding of human civilization and understanding of cultures can also advance. And much like this, scientists are using muon detectors called as CORMIS, Cosmic Ray Muon Imaging System. They have used it to examine the wall of Xi'an city. This is what the news is about. Now, from the exam perspective, we will cover the application of muon from various dimensions. But basically, the long and short of it, you understand. Muons are there in the atmosphere naturally, and we place detectors to detect the intensity. If there is difference in density, there will be difference in the intensity of muon received by the detector. So we can do the 3D mapping. That's it. That is the basic principle. And using this, we can have wide-ranging application of muon. So let's see area-wise, in which area, what kind of application we have. In particle physics, we have wide-ranging application of muon. You understand that muons are produced in large numbers in cosmic ray interaction, and they can be used to study cosmic rays and their interactions with matter. This way, the muon experiments can provide information on the composition and origin of cosmic rays, as well as the processes that occur in the high energy environment of cosmic ray interactions. You already know that weak force is one of the four fundamental forces, apart from gravity, electromagnetic force, and strong force. Muons have been used in experiments to provide insight into weak force, and they have resulted in the discovery of W and Z, these two types of bosons. Previously, I have told you bosons are force carrier, and there are different kinds of bosons. W bosons, Z bosons are common bosons. And you understand what weak force is. Strong nuclear force keeps the protons and neutrons binded within the nucleus. And weak nuclear force are responsible for nuclear decay, radioactive decays. So how boson does that and role of different kind of bosons, the study of that is enhanced by muons. Muons are also used in particle colliders, such as Large Hadron Collider. They are used to search new particles and new phenomena. For example, muons can be used to search for evidence of supersymmetry. Supersymmetry is a theory that extends the standard model to include new particles and interactions. I've told you standard model is not the final model because it doesn't explain many of the phenomena of nature. So the new theory that we make, they have to be tested. And that testing are done in the Large Hadron Collider using muon. Muons can also help in the search of dark matter. Dark matter forms about 27% of universe. And by detecting how muons are deflected by the presence of dark particle, scientists hope to gain a better understanding of this mysterious substance. Now let me bring you back to the slide so that things does not become very heavy. Muons are leptons, and leptons help in the interaction with the environment because of their spin. Muons are also heavy. They have high momentum, they have high penetrating power, and their disintegration is also fast. So it makes it a suitable particle to do all sort of experiments because its interaction is stronger with the environment. That's why in search of dark matter, in search of any new particle, in study of weak forces, in study of cosmic rays, in all these cases, muons can be used. Muons can be very well used in disaster management. Muons actually have been used in investigating the interior of Fukushima Daiichi nuclear power plant. After the 2011, if you remember, if you have ever read about it, in 2011, there was disastrous nuclear breakdown in Fukushima nuclear power plant in Japan. And then muons were used to help assess the damage inside the reactors. Muons are highly penetrating particles, you know that. And that helps to easily pass through the materials such as concrete, steel, and radiation shieldings, making them ideal for inspecting the interior of damaged nuclear reactors. Muography is also being used by researchers to analyze Mount Vesuvius. It's a volcano in Italy. According to a study done last year, with the help of this technique, muography, researchers are trying to understand the finer details of the volcano's internal structure. And there's a hope that this study, the data collected from here, will play a crucial role in predicting what hazard to expect in the eventual eruption. Muons can be used for all sort of medical imaging. We can use muography for non-invasive imaging of the interior of large objects, including human body. You know that muons can penetrate through steels, through rocks. It can also penetrate through human body. It can be used to do the imaging of bones, of organs, of any other internal structure of body, including cancer. You are aware that the cancerous cell has different density than normal healthy cell, and this difference in density can be used for imaging purpose. Different density means different absorption. So different intensity of radiation received by the receiver. And hence the difference in density would be known. So the tumors, the cancerous cells, can be identified by myography. Archaeology has advanced. Muons are now used to study ancient structures, ancient tombs, pyramids which are 4,500 years old but still holds lots of mystery and secrets. Because muons can penetrate solid rocks and provide a good 3D image of the interior. The Great Pyramid of Giza, it already has been studied using muon. In material science, muons hold huge potential. Muons can be used for non-destructive testing of any industrial material, including pipelines, pressure vessels, any critical components. By exposing the materials to muon and analyzing how they interact with the materials, engineers can detect cracks, corrosion, or any other defects in the material without damaging it. Muons are being used in experiments to study the behavior of superconductors, materials that can conduct electricity with zero resistance. By exposing superconductors to muons and analyzing how they interact with material, scientists can gain insight into the behavior of superconductors, and they can learn more about their potential use in various technologies. Similarly, muons can be used to study the properties of ceramics, glasses, any industrial material. Muons can be used to measure the level of ionizing radiation present in the environment, and this information would be useful for developing radiation protection systems. You understand, muons are present everywhere, and when there will be more radiation in any area, there will be interaction of muon with the radiations and hence destruction of muons. So measuring the intensity of muon, you can know the level of radiation in that area. This way you can also detect the nuclear weapons. Nuclear weapons are generally shielded in lead, but muons can tell us the presence of lead as well. It can tell us the presence of outer box of lead and what lies within. And hence muons are presently being used in some of the world's busiest ports and border crossings to detect the presence of nuclear weapons and any other radioactive materials. You know, muons can penetrate the metal casing of shipping containers and other vehicles, allowing them to detect the presence of radioactive materials without any physical inspection. So extending this idea, muons can be used for geological surveys. Muons can be used to detect the presence of minerals, metals, and any other substance inside in the ground. By detecting how muons are absorbed or scattered by different materials, scientists can infer the composition and structure of Earth's interior. Not only Earth's interior, we can actually do exploration of other planets. And the planet presently of interest for exploration is Mars. Mapping of subsurface structure of Mars can be done easily because muons can penetrate deep into the Martian subsurface, making it possible to use muons to create images of subsurface structures, including the rock formations or potential mineral deposits. Here you can compare this idea with remote sensing. Mineral exploration can also be done using remote sensing, and actually it is also presently being done on Mars. In remote sensing, you send a radiation. A part of it will be absorbed and a part of it will be sent back. So depending upon what do you get back, the spectrometer will be able to infer what lies beneath because different materials have different properties. Different materials will absorb differently and send back radiations differently. So that way you can know what lies beneath. Similarly, depending upon how muons are absorbed, you can know the same thing. What kind of material and what kind of structures. We can also know about ice deposits within the surface of Mars. And we can study the interiors of Martian surface as well. We can do the same kind of thing on Earth for soil moisture measurement. Remember, muon is not just going to tell you the property of material like rays. Here in remote sensing, you know the nature of material. And for imaging, you have to use radar. Muons will tell you both the property of materials, the chemicals, the bonds, the kind of charge, and also the structures. So basically, muons gives us 3D image along with the chemical properties. So it can be used in pharmaceutical industry to find out the structure of molecules, all sort of molecules. It can be used to know the structure of catalysts. So in click chemistry, as you would know, Nobel Prize in Chemistry has been given last time for click chemistry, and for other areas of chemistry and chemical engineering and pharmaceutical science, muons are very, very useful. So these are the general applications of muons that you should keep in mind for the purpose of your exam. There was another explained article this week. NASA ISRO partnership satellite all set to arrive in India. What is NISAR and its mission? NISAR is a joint Earth observation mission of NASA and ISRO. It stands for NASA ISRO Synthetic Aperture Radar, NISAR. This satellite is being jointly developed by NASA and ISRO, and recently it got a send-off ceremony at the American Space Agency's Jet Propulsion Laboratory. Now, this satellite will be sent to India in a special cargo container flight for a possible launch in January 2024 from the Satish Dhawan Space Center in Andhra Pradesh. So NASA has done its job and is in the process to hand over the project to ISRO, and ISRO shall most likely be launching the satellite next year in January. Let's quickly look at some of the features of NISAR. NISAR is NASA ISRO Synthetic Aperture Radar. This joint mission aims at studying Earth's surface and the changes happening on Earth's surface over time. NISAR is going to be the first satellite to use two different types of radar. The total weight of the satellite will be around 2,800 kilograms, and it will use L-band radar and S-band radar. L-band, S-band, C-band, X-band, Ku-band, K-band, K-band, you must have heard about them. These are the microwaves frequency bands. The L-band works in the range of 1 to 2 gigahertz, and S-band works in the range of 2 to 4 gigahertz. The L-band in NISAR will be used mostly by NASA for its science projects, and the S-band, which is a higher frequency band, will be used mostly by ISRO. Now, this is about radar. The general radar can work in these bands, but here we are talking about a special kind of radar called as synthetic aperture radar. Let me quickly give you a brief sense of synthetic aperture radar. See, aperture is the opening of the lens that decides the amount of light that gets into the lens. Higher the aperture, more the amount of light getting inside the lens and clearer the image. So if the aperture of the radar, meaning the size of the antenna, if that is larger, then the image that the radar will draw of any object on surface of the ground or anywhere will be more clear compared to a radar system where aperture is smaller. You can clearly understand the amount of light that will be reflected from any object. That's going to be the same for both the aperture. It won't of course change if you change the radar. The light will be emitted in 360 degree, but the amount of light that will be gathered by the radar will depend upon the aperture. The larger the aperture, the more light it will be able to collect, and hence the image will be more clear. But there is practical limitation of designing a larger size antenna of the satellite in the space. We cannot make the aperture of the radar or the size of the antenna enormously big. But the idea here in SAR is that the aperture of the radar is synthetically made large. And it is done simplistically by using the movement of the satellite itself. Suppose this is the radar satellite, and you know how radar works. Radar sends microwaves, not radio waves, it sends microwaves, still called as radar, because the concept is the same. When the satellite uses radar system, it sends microwave, and the microwave, some amount of it is reflected back. The time that it takes to go and come back, that is measured, and according to that, the distance is calculated because the speed of the microwave is known to the system. And in that way, the entire imaging is done. Suppose this is the object. So when the radar system sends rays here, it will take different amount of time to come and go back than when it sends the rays here because of the depression. And because of the precision in the system, these distances are very accurately measured. So these depressions and the curvatures and different shapes and sizes, it all can be mapped up. So this is how you know the shape and the size of the surface structure. But the thing is that the satellite is continuously moving. And because of that, the satellite after some time will come here and will start taking the signal from this position. So it is as though the aperture is this big and the rays can be received at any point in the aperture. So synthetically, by using the motion of the satellite, we have artificially increased the aperture size. That said, That's the rough idea behind synthetic aperture radar. But as simple as it may sound, it is not an easy thing to do practically. Because the whole thing is hinged on the precision of data receiving and processing. The motion of the satellite that has to be very well known to the system at what position the satellite is presently and how the radiation is being collected from the same object. Otherwise, theoretically, this is the idea behind synthetic aperture radar. And you understand, because of synthetic aperture radar, the aperture will become enormously big, and that will give huge precision to the system. And that will make the radar system immensely precise. So much so that it can detect movements on planet surface as small as 0.4 inches. So that's the thing about NISAR, or in general any SAR satellite, synthetic aperture radar satellite. You can measure the tiny movements on surface of the earth. And what can you do by measuring the tiny movements? You can track the subtle changes on earth's surface, including the incoming earthquakes. Because of warping or because of other movement of the plates, you can detect that something is happening. You can spot the warning sign for imminent volcanic eruptions. You can measure the melting glaciers. You can monitor the depleting groundwater as the water recedes down into the water table. That will also be known. We can do agricultural mapping. You can also know the land use pattern, whether there are larger trees or smaller shrubs or climbers, or you have paddy fields. Everything can be known. We can monitor the level of glaciers in the Himalayas. We can measure the changes in the coastline. We can also identify the landslide prone areas. All these things basically are hinged on the fact that NISAR can measure small changes on surface of Earth. And because we have one satellite and we would like to cover the entire surface of Earth, so it cannot go in the geostationary orbit. The only way to cover the entire surface of the Earth using one satellite is to use polar orbits or near polar orbit. The satellites in the near polar orbit, they scan the surface of the Earth very fast. And within the span of 12 days, NISAR will cover the entire Earth. In the NISAR system, NASA will provide the L-band radar, the GPS system. I told you have to know the position of the satellite very precisely. It will also provide high-capacity solid-state recorder to store the data. ISRO is going to provide the S-band radar, the GSLV launch system, and the spacecraft. Now you have two pieces of information here. It will go in near polar orbit, and the weight of the satellite would be around 2800 kg. So you tell me, do you need GSLV Mark III as a launch vehicle in this case? Let's quickly look at some of the applications of NISAR. If we begin from GS paper 3 from the geography section, NISAR will improve our understanding of the Earth's process. NISAR will provide new information about the Earth's surface, including the topography, the geology, the changes happening on the surface of the Earth over time. It will give us better understanding of glaciers and ice sheets, which will help to improve our understanding of the Earth's water cycle and its impact on the climate. And then you can extend the idea to different physical features. For example, the data from NISAR will also help us understand the distribution and changes of volcanic activity. So it will help to reduce the risks associated with volcanic hazards. Since it can measure movements on Earth's surface with high precision, so the NISAR's data will also be used to study Earth's crust and its movement, helping us understand earthquakes and Earth's tectonic process. If you look from the perspective of GS paper 2, in the international relation, the collaboration between NASA and ISRO will improve the strategic partnership between India and US. If you go to GS paper 3 and begin from economy, NISAR will improve agriculture and forestry management. It will provide important information about land use changes, including changes in agriculture and forestry practices. These will be useful for improving land management and food security. NISAR's data will also be used to monitor changes in the land use, such as urbanization, deforestation, land degradation. This will help to improve land management and the sustainable use of natural resources. We have discussed previously as well that radar data, especially synthetic aperture radar satellites data, can help us understand the distribution and changes in freshwater resources. Because the radar can measure the depletion in the water levels in water bodies like lakes, and also in the aquifers beneath the ground. In GS paper 3, if you switch from economy to technology, you can note that advancement in remote sensing technology will be ushered by NISAR. Because NISAR satellite will demonstrate the capability to use two different types of radar on a single satellite. This has not been done before. And this will have important implications for future remote sensing missions. Now, if you switch from science and tech to environment, biodiversity, ecology, you can observe that NISAR satellite will also be used to study climate change. It will provide valuable information about Earth's cryosphere, including the polar ice sheets, glaciers, permafrost, which will help us to better understand the impact of climate change and sea level rise. The Earth's atmosphere will also be studied by the NISAR satellite. So it will help us better predict the weather. Disaster management will be improved, disaster response will be enhanced, the extent of damage from natural disasters that can be assessed better by NISAR. NISAR data will also be used to monitor the coastal regions, including the changes in the sea level and coastal erosion, thus helping to reduce the risks associated with coastal hazard. In summary, NISAR mission has the potential to provide valuable information that will improve our understanding of the Earth and its processes and will have important implications for a wide range of fields, including earth science, environmental management, disaster response, improvement of technological ecosystem, improvement in international relation, among others. There is an article in the Hindu today, Millets for a Healthier Future. Let's quickly revise the overall benefit of millet.
Beginning from GS paper 1, we'll talk from the perspective of first geography, then society, and then culture. You know that around 60% of India's agricultural land is rain dependent. And large areas, as you can see in this heat map, they are arid, semi-arid. More clearly, you can see here, the region that falls into the category of arid or semi-arid, that is a large percentage of India's landmass. Also, in terms of land degradation, if you see in this map, the areas that have been recently seen land degradation is large. The degradation has happened because of various reasons like water erosion, because of water logging, because of salinization in the region of Punjab, Haryana, Uttar Pradesh, also because of wind erosion in the western part of India. So these are geographical constraints and problems of Indian landmass. And hence promotion and production of millet suits very well to the tropical location of India apart from the constraint of being monsoon dependent. If you move further into the syllabus of GS paper 1 after geography, you will find the syllabus of society. In the syllabus of society, you will find a topic poverty and developmental issue. And very often questions are asked from this section of poverty and developmental issues. From various studies, it has been seen that there exists a proper linkage between millet production, poverty reduction, malnutrition alleviation, and rural development. The linkage will become more intuitive and visible to you as we move further into our discussion. See, there are different sources for poverty estimation in India, and various sources have given the numbers between 37% and 77%. For example, Tendulkar Committee pinned down the number to 37%, 42% of poverty in rural India, and 26% in urban India. The Saxena Committee gave the number as 50%. Arjun Sen Gupta 77%. World Bank has estimated 42% of Indian population to be living below the standard international poverty line, that was of $1.25 per day in terms of PPP. And if this line is increased to $2 per day, then the percentage of population shoots to 80%. In terms of multidimensional poverty index of United Nations Development Programme, 54% of Indian population are poor. Associated with the issue of poverty is the issue of nutrition, and the nutritional status is also very poor in our country. According to the recently released data of National Family Health Survey 5, you would know that more than half of children and women are anemic in 13 states. There has been increase in the childhood stunting from the data released in National Family Health Survey 4. Prevalence of blood pressure, hypertension has also increased. And lifestyle-related diseases like being overweight or obese, their prevalence has also increased both among children and adults. Millet production is said to solve this problem of poverty and the problem of malnutrition. First of all, millets are drought resistant. They require very little external input in terms of chemical fertilizers, water supplies, and other inputs like technological inputs. So the cost of production decreases. They are also highly nutritious. They are rich in iron. They are richest in calcium. So they are good source of both food security and livelihood security. Because growing millet is easy even in rain-fed areas, especially in remote areas among the tribal population. Millets has dual purpose of both food and fodder. Agricultural productivity has very strong linkage with overall rural development. Indian Council for Agricultural Research has reaffirmed in various reports the power of agricultural productivity in reducing rural poverty. It says that 1% productivity increase reduces rural poverty by 0.65%. And agricultural productivity for millets can be increased very easily because of very little external input required. Millet also has one cultural aspect related with syllabus of GS paper 1. It has long history of production in Indian subcontinent. Reference of millets can be found in various mythology, poetry, religious practices, even in Ayurvedic recipes and various Indian dishes. Millets still today, they are a very important part of socio-cultural fabric in various societies in India. Now let's jump from GS paper 1 to GS paper 3. We'll come back to GS paper 2 after this. In GS paper 3, we'll touch two areas, economic development and environment. Under the syllabus of economic development, you'll find this topic, major crops. And in the topic of major crops, you'll find various subtopics. One of the subtopics is cropping patterns in various parts of the country. So definitely you have to cover millet in this topic of major crop because as we have seen before, millet is the fourth important food crop in India. So let me tell you a little basic. First of all, millets are photoinsensitive, meaning they do not require a specific photo period of sunlight for flowering. And millets are generally thermophilic. They grow better at higher temperature. And they also are xerophilic because they can grow well even in the condition of limited water availability. In contrast to millet, if you look at other important food crops in India, like rice, wheat and maize, wheat is highly thermally sensitive and it demands a very narrow range of temperature for growth. If that is breached, the production of wheat is adversely affected. But millets are so good, they have no such demands. Pearl millets, they can actually grow in a very poor soil condition as well. They can grow in sandy soils because they can absorb moisture from the soil very effectively. In the category of small millets, we have talked before, kodo millets, which has its origin in India, they can grow very well in adverse climatic and soil conditions. Millets, you must also know, follow the C4 photosynthesis mechanism. So their ability for carbon sequestration is high. So they actually contribute towards reduction of carbon dioxide. In contrast, if you see, paddy is one of the major contributors to climate change. Methane emission from the paddy field is very high because of rotting of organic matter beneath the water-drenched rice fields. Also, wheat and maize, they also have very high global warming potential. Millets, they do not attract pests and hence they are relatively much free from diseases, which also means that millets can be stored for a considerable amount of time under appropriate storage condition, making them famine reserves. Millets not only have lower carbon footprint, they also have low water footprint because the input demand for water is less. Rice needs actually 3 times more water to grow in comparison to millets. And when India has to support 15% of world's population with just 4% of water resources on earth, production of millet could be really helpful. In terms of economic development, we'll also talk about economic parameters. For example, employment. Millets are largely grown through traditional methods, although technology will help in the post-harvest process. But largely it employs traditional method for cultivation. So the employment support is higher. Millet cultivation can also prove to be sustainable income sources because of lower input cost and less sensitivity with respect to climate or weather. Capitalizing on production of millet will also help in the export because in Africa, 40% of the food demand is met by millet. And there's a big market for millet export in Africa and otherwise. When you do cropping pattern in the major crops within economic development of GS paper 3, you should note that millet has a short growing season of around 65 days. It can vary, it can go up till 135 days, but relatively it has a shorter growing season. And this allows it to be part of multiple cropping systems, both in rain-fed areas and irrigated areas. Also, as we have discussed before, millets more effectively sequestrate carbon. So it is very helpful for the other crop and hence can be utilized in intercropping system. Now we come to GS paper 2. In GS paper 2 syllabus, you'll find this topic, issues relating to development and management of social sector or social services relating to health, education and human resources. We'll focus on this part of health. And in health, we'll first do nutritional security. You must know that millets have higher levels of protein and they have more balanced amino acid profile. They also have higher dietary fibers, and these two means that they are easily digestible. Very helpful for both children and aged people. They are also rich in B complex vitamins like niacin, thiamine, riboflavin. They also are source of methionine, the essential sulfur-containing amino acid. Not only vitamins, they are also good source of minerals like iron, folate, calcium, zinc, magnesium, phosphorus. They also are good sources of antioxidants. Ragi, for example, is known to have highest calcium content among all the food grains. Millets also have very high iron content, and this can be strategically used to fight the prevalence of anemia. Millets also have phytic acid, and it is believed that phytic acid help in lowering the cholesterol level in body. Millets have nutrients like phytate. It is believed that phytate help in reducing the risk of cancer. You know, millets are gluten-free. Gluten are found in very high amount in wheat, and they have low glycemic index. Glycemic index of a food crop or any food indicates how they affect the blood glucose level. Low glycemic index means when you eat it, your glucose level in blood will not spike. So they are very beneficial for diabetic patients. Since they are easily digestible because of high fibers, they also are helpful for gastrointestinal disorders. Since it also controls the blood pressure, so it also helps patients with heart ailments. We have seen before that it has antioxidants. So if there is oxidative stress in the body leading to death of the cell and other complications, millets will also help in that case. We have already seen it has high iron, so will help in anemia. It has B complex vitamins like, for example, niacin, so it will help in pellagra and various other vitamin deficiency related diseases. Now I'm doing a little bit of extension because in GS paper 2 you also have international relation. You know, from 2013 to 18, India exported about 15.4% of world's bajra to around 60 countries. And you must know that more than 40% of global millet consumption happens in African countries. Also, because of its nutritional value, the food which are sent to war-torn areas, volatile areas, Yemen, Syria, even Myanmar, India can become an effective supplier of food, exporter of food to these countries. This will help engaging more with the African countries, compete better with China, and increase our soft power in West Asia, in some parts of Europe, and in some troubled areas in Asia. But the production of millet in India is gradually decreasing in terms of cultivated areas and also in terms of total production. Productivity although has increased for millet, but total production and cultivated area has decreased. Millet for a long time has been seen as poor person's food. It has been victim of policy neglect. Very little production support has been given to millet as was given to rice, wheat during the Green Revolution and to a certain extent to maize. Technological support for cultivation of maize is very little. Technological adoption for post-harvest process, although the government has tried by coming up with a scheme in 2012, but the post-harvest technological adoption still is very low. There is problem with remunerative prices. Although it has been included in the MSP regime, but the remuneration offered there for millets are low. It also has been seen that there has been changing preference in the consumption pattern even in the rural areas. Some suggest it has been because of transmission of culture, changing culture from the urban areas through the process some terms as Sanskritization. There also has been impact of mass media because of overt advertisement of packed foods. Rice and wheat-based packed foods are becoming more popular. There are very few brands or the formal sector companies working for promotion of millets. But now things seems to be changing. The year 2018 was declared as the National Year of Millets by the Government of India. And the Food and Agriculture Organization also accepted the request of Indian government to observe 2023 as International Year of Millets. Back in 2012, Indian government launched Intensive Millet Promotion Scheme. This was the part of Rashtra Krishi Vikas Yojana. The purpose was to advance the equipment and technology related to millet harvest. Also, as part of Rashtra Krishi Vikas Yojana, Rain-Fed Area Development Program was launched. The purpose was to identify new areas which are receiving adequate rainfall for millet farming. Government of India also has given the status of nutri-cereals to millets. It has been included in the system of PDS. Government of India also has recognized millets as anti-diabetic. Recently, MSP for millets was also hiked. Say in 2018, UPSC has asked this question. Consider the following: areca nut, barley, coffee, finger millet, groundnut, sesame, turmeric. The Cabinet Committee on Economic Affairs has announced minimum support price for which of the above. So you must know that MSP is given for millets and that includes finger millet. But it's a different issue. Only knowing that will not help you solve the question. But if you know that coffee, tea, these two are not included in MSP, their pricing has a different mechanism, then that will help you come to the right answer. Because if you remove the options having number 3, you will be left with only one option. But nevertheless, MSP are given for millets. Government of India is also encouraging millets to be included in midday meal scheme. Because why not? They are so nutritious. And millets are also being promoted under National Food Security Mission. But however, they are not promoted under National Nutrition Mission. There was a question in 2017 prelims examination. Which of the following are the objectives of National Nutrition Mission? To create awareness relating to malnutrition among pregnant women and lactating mothers, it seems obviously correct. To reduce incidence of anemia among young children, adolescent girls and women. There are actually targets given to reduce anemia, and this is also correct. Third statement was to promote the consumption of millets, coarse cereals and unpolished rice. And the fourth statement was to promote consumption of poultry eggs. But there is no such target to promote the consumption of millet or the coarse cereals or poultry eggs. So answer to the question was option A. Let me take you through another question of prelims 2016 with reference to Initiative for Nutritional Security through intensive millet promotion. Which of the following statements are correct? We have just seen that through intensive millet promotion, the aim of the government was to advance equipment and technology related to millet harvest. Now let's come to the question. This initiative aims to demonstrate the improved production and post-harvest technologies and to demonstrate value addition techniques in an integrated manner with cluster approach. Verbose but sounding true. Poor, small, marginal and tribal farmers have larger stake in the scheme. Yes, because millets are mostly part of dryland farming. The third statement, however, was this. An important objective of the scheme is to ensure farmers of commercial crops to shift to millet cultivation by offering them free kits of critical inputs of nutrients and micro irrigation equipment. This statement is incorrect 3 times over. First of all, commercial crops are also important. You cannot be encouraging farmers of commercial crops to shift to millet cultivation just like that. Second of all, whenever equipments are given to farmers, they are given at subsidized rate. Free kits like this are not given. And thirdly, we have seen that the millets have very little demand of inputs in terms of nutrients, input in terms of water. So free kits of critical inputs of nutrients are actually not given. But you must know that micro irrigation equipment are given for millet production. It is right. But subsidized support is there for it. And they are not actually free kits. In UPSC prelims examination, you'll find many questions in which you'll find long statements. Those long statements gives you many opportunities to find the loophole in the statements, and most of the times they are incorrect. Answer to this has to be